Hello. Slope is an important concept in math, and for right now, it only refers to lines. And for right now, you can just think of it as a measure of the steepness of a line. That's not a technical term, steepness, but I don't want you to know what it looks like intuitively. So here are some lines with some slope. Every line has slope, but here's a very steep line and it has slope 5. So 5 isn't a big number, but it makes for a very steep line. So we always go from left to right. So this line goes up as we go from left to right, or ascends. So it has positive slope and it goes up pretty steeply, right? So it has pretty high positive slope. Here's a line with some low slope. 1/8, that's a small number, and that's not a very steep line. So just think, if you'd rather not, if you'd rather ride your bike up that hill, you'd want the slope to be a small number. And if you wanted to ride your bike down a hill, well, that'd be a little extreme, but there's a line with slope -2. So you can see right away, negative slope corresponds with the line descending as we go from left to right. So here's how we measure that. If you look at that first line, the steep one, if you go over 1 unit, you're going to go up 1, 2, 3, 4, 5 units, right? And if you go over 2 units, you're going to go up 10 units. And if you go over 3 units, you're going to go up 15 units. So we define it by taking how much it goes up divided by how much it goes over. The technical terminology for that is rise and run. So for every one time it runs, and remember we always go from left to right, it rises 5. And it literally rises. Now, if it rose -5, it would technically go down 5, but that's totally fine and accounted for in the formula for slope. And there it is. So you have to remember that. A line slope, we use the variable m for slope for some reason. It's defined as the ratio of the rise to the run. So we take how much it goes up and we divide it by how much it goes over. Okay, so we'll spend enough time with this that eventually you'll just have it internalized and you won't even have to memorize it. You'll just kind of know it. If all we have is 2 points, remember we can just draw a line if all we have is 2 points. And not only can we draw, but now we can find something cool about it, which is its slope. So we use this formula, and let me throw a picture up. So take a second and draw that picture, because again, you have to remember this next formula, but I'd rather you just got why it was the way it is, and that way I wouldn't think about it as memorization, just think about it as, oh, you get it. So there's a line, then there's 2 points on it. We call the first point x1, y1, and we call the second point x2, y2. Now what we're going to see is it doesn't matter which point is called which. The formula works the same no matter what, so you don't have to worry about that. So we take its rise. So the amount it goes up is given by the literal difference between these two y coordinates. The difference, right? So the distance, you could think about it. So the distance or difference between the two y coordinates is y2 minus y1, and that's the rise, right? Literally difference. You subtract them. Same thing, the difference between the two x coordinates is given by the distance between the horizontal distance between x2 and x1. So that's x2 minus x1. And that's what gives rise to this formula for slope. This is just a little thing that I had to make clear because you'll see. If x2 were equal to x1, you would be dividing by 0 in this denominator. So that won't really be a problem, but anytime we bust out a mathematical formula, we also always have to be like, unless you divide by 0, in which case none of this stuff works. Okay, so that's it. So that's another thing that I'm afraid you just have to memorize. Given 2 points, x1, y1, and x2, y2, you find the slope of the line containing those 2 points with this formula. The difference in the y's over the difference in the x's. So internalize this picture. Pictures are worth 1,000 formulas and words. So if you get why it is the way it is, then you won't really have to memorize it. So you take the rise, which is the difference in the y coordinates, and then you divide it by the run, which is the difference between the x coordinates. This is the same exact formula, I just wanted to have it on this slide, because now we're going to do an example. So here's a line. We've got 2 points clearly marked. We can use any 2 points. You would hope that if I pick any 2 points on the line, find the slope of the line containing them, it's going to be the same, and it is, right? So these points aren't special, they're just the ones we marked. So the first thing you have to do is you have to know how to read 2 points. So that first point is -2, -3, and that second point is 5, 2. All right, and then you just have to use a formula. So it's certainly not hard, it's just subtracting numbers and dividing them. All right, so we're going to let x1 be the one on the left, the -2, -3, and we're going to let x2, y2 be the point on the right, which is 5, 2. And this is important, so you don't have to write this down, but just know that if you picked them the opposite way that I just did, this formula would give you the same number. So you don't have to worry about that. And you're more than welcome to check that by doing it a different way than we're about to do it. Okay, so the way we're doing it is 2 minus -3 over 5 minus -2. See it? So that 2 minus -3, let's see, is 5. So 5 is just the vertical distance between the 2 points. So 1, 2, 3, 4, 5, right? It goes up 5. And then 5 minus -2 is 7, so that's just the corresponding horizontal distance. It goes over 1, 2, 3, 4, 5, 6, 7. And the formula is nice because it doesn't matter if numbers are negative or whatever. It always works. So it's 5/7. So that's a slope that's a little less than 1. A line with a slope of 1 is perfectly diagonal, so it has like a 45-degree angle. So a line with slope a little less than that is going to be not quite diagonal, like our line. And if the line falls, what's going to happen? It's going to run a certain positive amount, but then you're going to take a negative number and divide that by a positive number, which means you're going to get a negative slope, which is totally right. Okay? So you don't have to think about any of that stuff. You just have to apply the formula and trust that, yeah, it works. The steeper your line is, the bigger the slope will be, and if the line goes down, then your slope will turn out to be negative. Here's a couple of important special lines, and we talked about like how you make the graphs for these. So these are perfectly valid linear equations, vertical and horizontal lines, but let's see what happens. So we always like to start with a picture. So you're going to plot the line between 4, 3 and 4, -2, and then you're going to think about like what could that slope possibly be. So 4, 3 looks like that, and then 4, -2 looks like that. Well, the line between them is vertical, and think about why. They have the same x coordinate, right? So they're lined up vertically. So let's try and interpret the slope for that. So it's going to be -2 minus 3 over 4 minus 4. And right away, your brain should be going, oh, nope, can't do it. That cannot be, right? We have 4 minus 4 in the denominator, and you know that that's a denominator of 0, and a denominator of 0 is completely illegal. That's the one thing that just completely breaks math. So it doesn't matter if it's 5 over 0 or 1 over 0 or negative infinity, or not infinity, negative a million over 0. Okay, it doesn't matter. That expression is, remember the word we use for that? Starts with a U. It's undefined, has no mathematical meaning. So that's it. The slope is undefined. So however you remember that, you just have to remember that a vertical line, it's not that it has 0 slope or whatever, or infinity slope. It's just, we just say that the slope is undefined. In other words, the concept of slope does not apply to vertical lines. Generally true. Doesn't matter where it is. If it's vertical, it does not have slope. Okay, now just do the same move, but with a line through the points -5, -2, and 3, -2. So picture them before you graph them, they're going to be lined up. So the y coordinate is the same, right? So they're going to lay on a horizontal line. Like so. So now do the same thing. Try and find the slope between those 2 points, but think about it first. Like, think about it in a rational way. If we've defined slope as a measure of steepness, and I said, okay, very steep is very high slope, and not so steep is pretty low slope, and negative slope means we're pointing downwards, what do you think the slope of a horizontal line should be, right? Hopefully you think that it should be 0, because it doesn't slope at all, and it is. Right, so whatever's in the denominator, 3 minus negative 5 is 8, but in the numerator, negative 2 minus negative 2 is 0. So the 8 didn't really matter. 0 divided by anything is 0. So that's a very important distinction. 0 divided into 8 is okay. You can chop nothing into 8 pieces, okay? But 5 divided by 0 is not okay. You can't divide something into no pieces. So the horizontal line is slope 0. And that is generally the truth. So you just have to remember that. A line that is flat doesn't slope at all, so it has slope 0. A line that is perfectly vertical, you can't really even say that it doesn't have slope. The concept of slope does not apply to, so we just say the slope is undefined. Okay, so however you have to remember that. Okay, so now we have to draw a line given only 1 point and its slope. So I'll show you how to do that. First, to draw the point. There's the point, negative 1, 3. That should be pretty easy for you. And then, so if we say this line has slope negative 2/3, the easiest way to think about that is this. Is to think about it as negative 2/3. You know that's the same thing as negative 2/3. So if you just always think of the run, right, it's rise over run. So if you just always think of the run as positive, then you're always going from left to right. So you run 3, and then that means every time you run 3, you rise negative 2, which really means you go down 2. So that's the process. You're going to go over 3 and down 2. Like that. So you just literally draw a little horizontal line, go over 3, and then draw a little vertical line, and since it's negative, it goes down, and you go down 2. Now, if you would have went backwards negative 3 and then up 2, it would have worked as well. I just think this is an easier way to think about it because you can just always think of run as being positive. So you're always running from left to right. All right, and then we've actually found another point on the line. It's 2, 1, but we weren't really asked for that. We were just asked for a nice drawing of a line. So now, since we have another point, we can just connect them like that. That's it, and that's all we were asked to do. We were asked to draw the line and, you know, make it pretty good. So on this exam, you're definitely going to be drawing some stuff. And by some stuff, I mean lines. Let's do a couple of examples of how this pops up in the real world, because it does. And it pops up in a lot of higher mathematics. You spend a lot of the calculus 1 talking about slopes of things. You may have heard this word before. If a road has a vertical rise of 120 feet for every 800 feet of horizontal range. So in other words, if you rode your bike on this road for 800 feet, like on the map, and then now you're 120 feet higher over sea level or whatever than you were before. So you've gained elevation, and this is specifically this much. So the word for that is the grade of the road. So the slope of a road or whatever else is sometimes referred to as a grade. So the bigger the slope is, the steeper the road is, right? Same thing. And then just always remember it's rise over run. So it's how much you went up divided by how much you went over. 120 over 800 obviously simplifies, and you want to simplify it. And let's just simplify it as a decimal for our purposes right now. So it's 0.15. So that's a pretty small number, which is right. We would expect that. So it wouldn't be that hard to ride your bike up this road, right? The only other thing is oftentimes this number is expressed as a percent. So you just convert it to a percent by moving the decimal place over twice. So now you know what that means. If you hear that a road has grade of 15%, that means that its slope is 0.15. So like if a road had a grade of like 1, that would be a perfect diagonal, which means it'd be pretty hard to ride your bike up, but that we would call that 100% grade. If it could certainly have slope bigger than that, right? It could be more than diagonal and be real hard to ride your bike up, and then it would have more than 100% grade. So ideally we want one with this pretty small grade like 0.15, and that correlates to 15%. So a road with 0 grade is just a flat road. One more, and this is actually probably the most important thing we're going to touch on, but I am literally just going to touch on it because it's only an algebra class. So another way slope pops up is a concept called average rate of change. All right, so follow along with me. This is just one example of many examples of calculating an average rate of change. In 2015, one share of a stock was valued at $4.50. And in 2020, that same share, one share, was valued at $635. So that's good. It went up. Hopefully you bought some back in 2015. So it's pretty easy to conceive of, okay, we want to think about, so the stocks don't just go up like a straight line. Like many things in life, they bob and weave, right? They go up and down. But we want to talk about like their average. How much did it go up per year on average? So obviously it went up. It went up, let's think about this, $185, right? It went up $1.85 in 5 years. So right off the bat, you can think, oh, the average amount it went up per year is just we go $185 divided by 5 years. That's easy to do. We'll do it now. So that should kind of remind you of finding slope, and it is. So if we take those 2 points, and I will in a second, if you think about, okay, if we make an axis for time, 5 years transpired. And so we're going to take the amount it went up, which is 635 minus 450, which is $1.85, and we're going to divide that by that 5 years, which is exactly like rise over run. Okay, 635 minus 450 is 185. Obviously, 2020 minus 2015 is 5, you know, because just 5 years went by. 185 over 5 is 37. So on average, the stock, we could say will go up, we could say did go up, whatever. This is what modeling is. So over the last 5 years since you bought it, it went up an average of $37 per year. Again, not exactly how stocks work, but that's okay. For anything, we can always calculate its average rate of change. So let's note a couple things on this cute little graph I made. Notice this is the number 15 and not the number 2015. There's absolutely nothing wrong with starting time at whatever suits you. If we always started time at the year 0, I mean, that's like biblical time, right? So we don't know a lot about what was happening then. We know what was happening in the last, 20, 30 years. So I just, for my purposes, started time at the year 2000. You could technically start time at the year 2015. This would just be a 0 instead. I think it's a little clearer if this is a 15 and then over here we have a 20. So in the 5 years from 2015 to 2020, it went up $185. So that's a slope of 37. Now you'll also say, well, this line doesn't look very steep at all. It's supposed to have slope 37. Sure. But to do this problem, notice I had to squash the y-axis. So there's nothing wrong with that. Scale is a whole thing. If we're talking hundreds of dollars or thousands of dollars, then we're going to want to squash the scale of the y, like imagine you're graphing it on your calculator, so we can see what's going on, right? And we could have units that are a heck of a lot bigger than that, or stuff that transpires over a heck of a lot longer than that, like carbon dating or something. So in order to see the information we want to see, oftentimes we have to do that. We have to mess with the scale. So be sure you get that picture. And then be sure, I'm definitely going to ask you on the test for something's average rate of change. So just think when you hear rate of change, just think of the speed of your car. It's miles per hour. So you're always dividing by time. Time always runs. So this, instead of being an x-axis, would actually be like a t-axis for time. So you're always just taking how much something changed and dividing it by the time. And if something went down, if your poor stock went down, well, that's fine. You take that negative number and divide it by time, and lo and behold, you get negative slope. So everything works out fine. Okay, so that's, I can't even tell you how important of a concept that is, average rate of change. So be sure you get why that is the way it is, and be sure to try those problems, particularly on the homework. Okay, thank you.